Yep, look at that. Here's the volume we're going to be looking at. The volume of a liquid here. You could see on the blown up view here, it's the volume between 50 and 40 mils. So you always choose the smaller number when you're looking at the volume between them. In this case, it is 40 mils. So the smaller whole number one here is 40 mils. So take that as we look at the volume. Step 2, we're looking at the smaller volume here. So we looked at 50, and we're going to have a look at the number of increments here, and you could see it's 1, 2, 3 increments. So there are 3 increments above the 40, and we could see the meniscus here. I'm just going to write meniscus just like so. Now, how do we measure the volume of the liquid? Well, we've got 40 here. We're adding the bits and pieces here. We've got 1, 2, 3, and that's 3 increments, which happen to be 3 mils. So if we add the 40 together here, plus the 3 mils, we'll get a total of 43 mils. Now, in the next slides, we're going to work out how we work out a scale. Let's have a go. Now, the first step is here, we're looking at where the meniscus is between the values of 50 and 40. Note the numbers 50 and 40. Now you subtract the higher number from the lower number. I'm just going to put that in green. I'm just going to put here. So the higher number here is 50, and we're going to subtract 40. We're going to count the increments between 40 and 50. So it starts here. It starts here and ends here. So into little crosses, increment. There's 1, there's 2, there's 3, there's 4, there's 5, 6, 7, 8, 9, 10. So there's 10 increments between. So if we divide that by 10, 50 take away 40 divided by 10 is 1. So each fraction of the unit is 1. In this case, 1 mil. Hence we got 40 plus 3, which is 43 mils. How to measure the length of an object. So here we have a little red object here, and it lies between, this example, it lies between 2 and 3. So you've got 2 and you've got 3 here. Here, if we draw it above me, the smaller value again, you choose here. You can see it's coming down here. The smaller value is here too, so we know it's between 2 and 3. And the end of the object, remember, it starts at the 0 point here, the 0 point. So you don't have to do any subtracting or adding, it's already there. Now you count the number of increments in between that ends at the line, and you can see here we've got 1 increment, 2 increment, 3 increment, sort of about pretty close to halfway in between, isn't it? So we've got sort of 3.5 increments. So when we take it from the lower number here 2, and then we add the rest, we check the scale. Again, as we did before, we add the number 2, which is here, and then we add 3.5 that we got. We'll show you in a second how we worked out the scale. So 3.5 over 10, and then we've got 2 plus 3.5, which gives you the answer 2.35 centimeters. So the length of this line from here to here is 2.35 centimeters. Let's have a go. Again, same sort of reasoning behind how you work out a scale. This is how we do it for this object with the different units. So you determine where the object ends. Here it is. It's ending here, ends between number 2 and 3. Let me draw that in. So there's the end of the object. And we subtract the higher value from the lower value. In this case, it is 3 take away 2. So I'm just going to do 3 take away 2. So we do the higher from the smaller. And then we count the number of spaces. So I'm just going to use this as an example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 increments that we can see between the two numbers, or which is 1, and that's 1/10. We know that as 0.1 as a decimal. So each value here, these little values here, are worth 0.1 of a centimetre. Okay, let's see how much we know. This is some questions I'd like you to answer. Quick 3, and see if we can determine that. Can you answer the following questions? The answers will follow shortly, but pause this video after each question. Find the length of the red object given below. So we've got a measuring length here, starts here, and it ends here. Write down your answer. With your quick 3, find the volume. I'll just put a pen in here. We'll do orange. Find the volume of a liquid shown in the measuring cylinder. So here's a measuring cylinder here, A, and we've got B. So here's the volume here for this one, and then see if you can work out the volume here for that one. There's the meniscus here. Just highlighting that for you. Press pause, write down, work it out, and the answers will follow shortly. Here we are with the final question. Change the following units of length and volume. So I want to change 123 centimeters into meters, and I want you to change 45 centimeters cubed into 1 liter. Pause the end of this and have a go at your answering these questions. Okay, here are the answers to the quick 3. Number 1, hopefully you got 8.7 centimeters, and you noted that you could see your scales between 80 and 90 millimeters. I want it in centimeters. Here's the answer to the second question. Find the volume of the liquid as shown here. The answers are A is 7 mils. Yep. And 250 mils as per the scales there. I hope you got that. If you got that, well done. Good job. Okay, the answers to the final quick 3. Change 123 centimeters into meters. Remember the rule, 1 meter is 100 centimeters. So you divide that by 100, and you get 1.23 meters. The next one, 45 centimeters cubed into liters. Remember your common conversion unit, 1 liter is 1,000 centimeters cubed, so you divide 45 by 1,000 and you get that value 0.045 liters. Well done if you got those correct. Good job indeed.